Good morning, S3. Today we're going to look at response and survival controlling your body. By the end of this section, you will be able to describe how the body regulates its temperature inside, so its internal temperature, describe how the body regulates its water balance, how much water there is in the blood and in your cells. You're going to be able to describe how the body regulates its sugar balance as well. So again, we've talked in the respiration topic about the fact that cells need sugar. So how do they get it and how do they keep it so you're not too sugary or too, bitter? We start by looking at your temperature. So we're going to understand how the body's temperature is regulated. So over the course of the day, your body temperature will change. You'll go into hot rooms, you'll go into cold rooms, and yet the actual inside body temperature will stay the same. If your body wasn't able to control this temperature, every time you walked into a cold room, you would become cold, and every time you walked into a hot room, you would become hot. There's lots of animals, like certain types of reptiles, that do this. They get hot in hot rooms and cold rooms, but we don't, and how and why? The answer would be because your health depends on it. So you'll be able to name the organ that senses change in your body and measure your own body temperature. We'll look at a few ways you can do that at home. For balancing your systems. Your cells, your tissues, your organs will only work at the right temperatures. The brain in your body is able to maintain these conditions by carefully monitoring your internal environment, so what's happening inside your body. If your brain decides something has changed, it will attempt to correct this. So this is a picture of the head with the brain, and we've got a section of the brain lit up here. So body temperature. There's several different types of thermometers that we would use in school to measure your body temperature. There's a digital one, so there's this one here. You might have one of these at home. Some of the tasks today, I'm going to ask you if there's an adult in the house, which hopefully there is, to see if they can tell you where you might have some of these thermometers. So if you want to pause the video just now, go away, ask that adult if they live in that house, do we have a thermometer? It's for school, and see if you can get hold of one. It'll either be digital, it'll be one of these ones that uses a liquid. So as the temperature goes up, the liquid expands and fills up the tube. Or you can get these liquid crystal chromatography ones over here. So have a look at it and see which one you have in your house. Humans live in lots of different temperatures. Like all mammals, we are what are called endotherms, so we are warm-blooded. That means that our body temperature will remain at about 37 degrees at all times. It doesn't matter if you're in the middle of the desert or if you are a native North American who lives in the freezing cold all the time. However, if in the desert your body didn't control the temperature, your enzymes, so the proteins that allow your body to work, would change shape and no longer work. And at under 37 degrees, these enzymes wouldn't be able to work very fast. So again, you wouldn't be doing very well. Our bodies try to maintain the temperature at 37 degrees as this is the best temperature for enzymes to work. So how does that happen? How do you maintain your body temperature when you get really, really cold? So when you get cold, the hairs stand up on your body. This is because when we were a bit hairier than we currently are in evolutionary time, this would trap a warm layer of air around your body. So the air basically gets kind of stuck in this hairy layer and it keeps you nice and toasty. If you get really, really warm, you might sweat and you might get a bit flushed. So if you're warm, you tend to go a little bit red, and if you're cold, you tend to go a little bit pale. We'll talk about why that is. So responses to overheating. When the inside of your body starts to get hotter, your brain recognizes this. Tiny little changes to your body temperature, 2-3 degrees hotter, if you get into the early 40s in temperature, you start not to do very well. So that's a tiny little change. What happens is the blood flows to the outside capillaries of your body, right to the very surface. Your cheeks look really, really rosy because of this, because the blood is at the very, very outside of your body, so you get quite flushed. What that means is that the heat is right at the outside of your body, so it's able to evaporate off and run off into the outside air. So this is a good way for your body to get rid of excess heat if it's quite warm. You'll sweat because the heat will go into the water and then the water itself will evaporate. So it's a good way to get rid of the heat by sweating. So the sweat glands will release sweat. That will then evaporate due to body heat and external heat, and that will help to lower the body temperature. So it puts all its hot blood near the surface of the body, that heats up the sweat, and then the sweat evaporates. This is just to clarify it. There's a process called vasodilation. That is the process where the capillaries at the outside of your body get nice and wide, and the blood flows near the skin. That's just a fancy name for what I talked about before. The hairs lie flat. They don't want to do that thing I was saying where they trap a layer of hot air. So when you get really, really warm, the hairs on your body will lie quite flat, and you will sweat for the reasons we've talked about. So a lot of people wear antiperspirants to stop themselves sweating, but sweating is quite good. It's one of the ways your skin can keep its body temperature quite constant, and not much air circulates under your armpit. So really, the sweat that's coming out there isn't doing an awful lot. Antiperspirants and other deodorants do stop you smelling. On the opposite end, here we go. Response to cold. There's muscles that control the hairs on the outside of your body. When it gets cold, we've talked about this before, the hairs stand up on end. That's because these muscles contract. Blood is diverted away from the skin. So we talked about in the hot section, if the blood goes to the surface of the body, it will evaporate the heat away. You don't want that if you're cold. So the blood is diverted away from the external parts of your body. If it gets really, really cold and your body's worried you might not be doing very well, it will send most of the blood away from your peripheral parts, and sometimes they can fall off and die if it gets exceptionally cold, just because they haven't got any blood. And this helps to maintain your core body temperature. Your body's only trying to heat a tiny volume of the blood then in the very center of your core. It doesn't have to worry about all the bits that are on the outside of your body that are losing heat. And much like before with vasodilation, a process called vasoconstriction means we appear quite pale. So all the blood is diverted away from the outside of your body, so your skin takes on quite a cold looking appearance. We shiver, so the muscle fibers contract really, really fast. That helps to generate heat, and it raises your body temperature. So that's why you shiver on a cold day. So we've talked about this in a little summary. Vasoconstriction, so these blood vessels here contract down so the blood can't flow through them, and the blood is kept at the center of your body. The muscles that control these hairs here will contract and they'll stand on end, hoping to trap a layer of warm air. Your body starts to shiver and you will not produce sweat. You can do an experiment at home that will show you vasoconstriction and vasodilation. If you go to the kitchen and get a box or a tub and fill it with warm water on one side, and you get another tub with ice cold water on the other side, and you put each of your hands into these buckets, contract them so they're under the water squeezing, and then take them out, you should see that your hands will change temperature. A very cool thing that you can do is another experiment where you put your hand in tap water and see if it feels hot or cold. If you then put your hand into the ice cold water for 30 seconds and then back into the tap water, you should feel like that tap water is absolutely roasting, because actually your brain got used to the ice cold water and adapted, and then when you put your hand in the tap water, it felt really, really hot. Similarly, if you put your hand in the warm water basin and then back into tap water, you should find that it feels absolutely freezing. There's an interesting thing where if you blindfold someone and put their hand into either ice cold water or actually really quite warm water, they don't know which one it is. Your body's very good at knowing its hand is in an extreme of temperature, but not actually very good. Without the context of seeing the ice or seeing the steam, doesn't really know which is which. Please do not try this on a younger sibling and burn them, because I'm not taking responsibility, okay? So if you're going to do this, do it to yourself, not to someone else. You might, if you look around your house, also find a thermos flask. So thermos flasks are based on a sciencey thing called a Dewar flask that was invented by James Dewar, who went to Dollar Academy, which is not very far from Kinross. So essentially, layers of glass, air, and insulating materials are put on top of each other in a proper Dewar flask. And that means you put something that's very hot or very cold in a bottle and it will stay like that. So, next lesson, we will go on to look at the control of water. Hopefully, we understand how your body stops you getting too hot when you're cold or too cold when your body is hot.